Most of our cosmos is dark.
So today we're going to check out some places that has a high probability of having life in the solar system and outside the solar system perhaps. But our first case here will be in the solar system. Let's actually go to Jupiter and a Galilean moon by the name of Europa. Okay, so this is Europa right here. All right, now a while back, it would have been unheard of to believe that life could exist this far out in the solar system because it's so far from the sun. At one point, we thought that all life on our planet in one way or another got its energy from the sun in order to live, for its metabolism. You know, in order to live, all life was dependent on the sun. And then we found out that that is not true, that, you know, there are some life forms down, you know, on the sea floor that gets its nutrients and energy from hydrothermal vents. So, and that's completely in the dark. So the sun, it's not providing those life forms with the means to live. And the same could be true on Europa, because from looking at this picture, what you do not see is that this moon basically has an ice shell, but underneath that ice shell is supposedly a liquid ocean of water, of salty water, which does have organics in it. They come to this conclusion because of all these cracks and lines and stuff, like as you can see right here. You see the surface here? Like this is reminiscent of like sea ice, like in the Arctic and stuff like that. So basically what's happening is this moon has a solid ice shell around it, but underneath is a ocean that could be 100 kilometers deep, which is salty. And the reason this could be is because the core of the moon is hot from tidal forces, tidal friction, because its orbit around Jupiter. Let's see if we can zoom out here a little bit. Its orbit around Jupiter is what you would call elliptical, which means it's not a perfect circle. So at some points it's closer to Jupiter, at other points it's farther away from Jupiter. Being closer and farther, what that does is flexes and squeezes the moon. Just like if you were to bend a wire hanger in your hand or a paper clip or something like that, you keep bending it, it's going to get hot. And that's the same thing that's happening in the core of Europa. And that, what that does is heats up the core, and what that would cause is like hydrothermal vents, or, you know, first volcanoes, but because there's a large liquid ocean on top, it would be hydrothermal vents, and that keeps the ocean liquid. That also provides nutrients, and when that salt water is in contact with the rocky mantle, what that does is give possible, you know, microbes or life forms of means of energy, and that can kind of create a sort of a biosphere down at the bottom of that ocean, you know, like a food chain. So let's see if we can go back to Europa here. Okay, so that's basically it. But again, that's the moon Europa. It has a salty liquid ocean underneath that ice shell. Europa, it's a Galilean moon. Obviously Galilei discovered the 4 largest moons of Jupiter. That's why they're called the Galilean Moons. It's the smallest of the Galilean moons. You know, Jupiter is like a mini solar system in itself. It has so far about 80 known moons, probably has more than that. It has a radius of 969 miles. It's 390 million miles away from Earth. It was discovered January 8th, 1610 by Galileo, or one of his contemporaries or something like that. Now, Europa, it's smaller than Earth's moon. It's made of rock. It has a water ice crust and probably a iron nickel core. It has a very thin atmosphere of oxygen. All right. Like our planet, Europa is thought to have an iron core, a rocky mantle, and an ocean of salty water. Unlike Earth, however, Europa's ocean lies below a shell of ice that's probably 10 to 15 miles thick, and the ocean has an estimated depth of 40 to 100 miles. So that's a thick ocean. You know what I mean? So there's no telling what kind of life forms could be alive down there. But just wanted to point out a possible place where there could exist life in our solar system right now besides the Earth. Let's bring in another representation of Europa here. And what I want to really get to is to look at the core of the moon so we can kind of see what's going on. But you see all these crisscross and these chaos regions and all this stuff right here? You see all that? Basically what that is it looks like, see that? It looks like broken up glaciers, because what's happening is as the tidal forces are acting on the moon, it's heating it up and the ice is breaking apart, and then water, softer ice that's a little softer than a frozen ice shell is coming up and filling in the space, and then it's freezing back solid. So this looks like sea ice, like very similar to sea ice up in the Arctic. And let's take a look at the core. So look, this is what we believe the core is like inside Europa. So just like Earth, it has an iron metallic core that's hot from the tidal heating. All right. And then we have the rocky interior, which would be like a mantle, I guess. And then further above that, then we have the ocean here. This is the ocean. All right. And here's the rocky interior. Here's the hydrothermal vents. Here's the salty ocean. And then the icy shell. So it's just something to think about. And again, obviously they haven't proven any of these things for sure, but just from like some of the probes and missions that's flown by and taken measurements, the moon has a magnetic field. All right, and the only way the moon could have a magnetic field is if there is some type of salty liquid or something that obviously creating an electric current or some type of friction or differential between the solid mantle and rocky part of the moon and the salt water. All right, so that's how they've come to that conclusion. But yeah, just wanted to go over this place here to kind of show you guys that this is a possible oasis for life right here in the solar system.